So this is problem 3D on the AP Chemistry buffer problem set. This is the big money problem. So I am adding 0.02 molar OH minus, again if you need to know how to get that concentration, watch the video for 3A, to a buffer system. It's a mixture that contains 0.1 molar HC3H5O2 and 0.1 molar NaC3H5O2, and that's from problem 1B. So when I set that up, I know this OH minus is going to react with the acid part of my buffer because this is the base. So my first part of this problem is to show that reaction. So OH minus plus the acid part HC3H5O2 is going to react, just the arrow to the right, and give me H2O because it's an acid-base reaction, so it's going to be neutral, and then C3H5O2 minus propanoate ion. So I have an initial change in my end result. So I'm going to start initially with 0.02 molar OH minus. How much of this do I start with? Well, if I look at problem 1, it's 0.1. I don't have to worry about water, but I also start with some of the propanoate. I actually start with 0.1 molar. And my assumption, based on the buffer, is that all the OH is going to be consumed unless it exceeds the buffer capacity. So what that means is if I take 0.02 away, I still have to be able to have enough acid to take 0.02 away. But I definitely do. What that means, this didn't exceed the buffer capacity. If this was greater than 0.1, then it would have exceeded the buffer capacity. So I'm going to add 0.02 to this side now. When I get my change, I have about no OH minus. I would have 0.08 molar propanoic acid and 0.12 molar propanoate. Now, given these ending concentrations, my buffer is going to reestablish its equilibrium. So I can write down my equation for my buffer. I like starting with the acid first if possible because then I don't have to worry about using KB and figuring out what KB is. And I make my ice box. So looking here, my initial concentration of the propanoic acid is 0.08. My initial concentration of propanoate is 0.12. Don't have to worry about water, and I have no H3O plus to start. So my change, it's got to go to the right because I have no H3O plus to start with, so it can't go to the left. So minus X plus X plus X. This should all look familiar. Very similar problems. So now I have my concentrations, 0.08 minus X, X, and 0.12 plus X. I write my Ka. And if you look at problem number 1, it will give it to you for propanoic acid, 1.3 times 10 to the negative fifth. That equals X times 0.12 plus X divided by 0.08 minus X. As usual, I can get rid of the plus and minus X, so let's do this math out. 1.3 times 10 to the negative fifth times 0.08 and divided by 1.3. Oops, I typed that into my calculator wrong. So hopefully you have an answer before I do. And this is in order to solve for X. I got that X equals 8.67 times 10 to the negative 6. So X is my concentration of H3O plus. If I look, that is the same as H3O plus. So my pH is the negative log of that. So if you put that in your calculator right now, don't be lazy and make me do it. Negative log, that answer. I get that the pH is 5.06. Now, my suggestion will be to watch the video that says problems 1 through 3 summary. It's going to talk about why this pH stayed very similar to the original pH of the buffer, but many of the other pHs changed dramatically.